Okay, so let's check this problem. Subarrays with k distinct integers, right? So in the input, we are given an array, an integer array, and we are given another integer variable called k. And what we need to do is we need to find the count of all the subarrays in this particular array such that in each of the subarray, we have exactly k number of distinct elements, right? K number of distinct integers, right? So for example, in this example, if k is equal to 2, if you see over here, if I consider just one, which is a subarray, it has only one distinct element. So that is not a valid subarray that I'm looking for. If I consider 1, 2, then I have two distinct elements over here, which is equal to the value of the k. So this particular subarray will be a valid subarray for me. Now, if you see 1 to 1, again, it has just two distinct elements. Then 1 to 1 2, again, just two distinct elements. Now, if I see 1 to 1 to 3, then I will have three distinct elements. And so that will not be a valid subarray for me, right? Because it has more than k number of elements, distinct elements, right? So if you see over here, if in this particular example, you will get exactly seven such subarrays with which has exactly two distinct elements if you go on to actually count that. So that's why my output is 7 and that's what I need to return. So this is the entire question. Maybe you can just try to solve this particular question on your own. And then once you are done, maybe you can come back and have a look at the solution, right? So now, if you think about solving this particular question, that is to find the subarrays with exactly k number of distinct elements, you will realize that doing this, finding subarrays with exactly k number of elements, distinct elements, is a bit tricky, right? But what is a bit easier is that if we find all the subarrays which has at most k number of elements, right? Not exactly k distinct elements, but at most k distinct elements, right? That is something which can be solved, right? And if we can do that, then what we can do is we can find all such subarrays for k equal to 2, and then we can find all such subarrays for k minus 1, right? So what will happen is, for example, let me just write it over here so that it's clear. For example, my function to calculate count of subarrays with at most distinct integers is f. So if I first do it for k, and then if I subtract f of k minus 1 from it, I will get uh, the count of the subarrays with exactly k elements, right? So why will this be true? Because for example, let's take an example over here. Let's say k is equal to 3 over here. So now first if I find, all the subarrays with at most three elements, three distinct elements, I will get all the subarrays with exactly three distinct elements as well. I will get all the subarrays with exactly two distinct elements as well, and I will get all the subarrays with exactly one distinct element as well, right? So that's what I'm going to get from this particular function fk. Now if I do fk minus 1, which is f of 2, that is all the subarrays with at most two distinct elements, I will get all the subarrays with exactly two distinct elements, and I will also get all the subarrays with exactly one distinct element, right? And now if I subtract this from this, right, this from this, I will get, my result will be, I will be just left with all the subarrays with exactly three distinct elements, right? Because the subarrays with exactly two and one distinct elements are also over here, which I'm subtracting from this particular, you know, output. So that's the intuition, that's the trick to solve this particular question, that if you can find all the subarrays with not exactly k elements, but um, at most k distinct elements, then you can do that particular function twice for, k and k minus 1, and then their difference would be exactly your output, right? So that's the intuition. So now to find the count of the subarrays with at most k distinct elements, let me just make it back to 2. What I can do is I can use a sliding window technique over here. I can use a two-pointer approach. I will have a left pointer and a right pointer, right? So initially my left and the right pointer would be at index 0, over here 1, right? Now I will like keep a track of the distinct count of the elements that I've seen so far, right? So over here my distinct element count is 1, right? There is just one element that I've seen so far. Now once, and then I will keep checking that at every step as I'm like moving forward, I will keep checking if that distinct count of elements is less than or equal to k or not, right? So if you see 1 is less than equal to k, right? So now what I will do is I will move my right pointer to 2, which is the next element, right? And over here, I will again see like what is my distinct count of elements that I've encountered so far. If you see it is 2, so now I will update my distinct count variable to 2, right? Similarly, then I will just keep moving to 1, then 2, and I will keep doing this till I hit a point where my distinct count of elements become greater than k. right? So over here, if you see, once I reach my right pointer over here, my distinct count of elements will become 3, whereas my k is 2. So that's where I need to stop, and now I need to start shrinking my window, right? Because now I want to like again make that condition meet where my distinct count is less than equal to k, because that's what I'm trying to do, right? I'm trying to find all these subarrays with at most k elements, right? So my distinct element count should never be greater than k. It can be either equal or it can be less than k, right? So that's why once I reach over here, now I will start shrinking my window, and the way I will do it is that I will start removing one element from the beginning, and I will just keep incrementing my left pointer now, right? And I will just keep incrementing it till the point where again my distinct count of elements will become less than or equal to k, right? And once I encounter such a point again I will start expanding my window. And now what we can do is at every step we will just keep incrementing. So we will keep checking that if my distinct count of elements at that particular step at that particular point is less than or equal to k, right? If it is less than or equal to k, then I will increment my total subarray count, right? Because now I have encountered new subarrays with at most k elements, right? And the way I will do it is I will do it using this condition, this formula. For example, CNT is the variable where we are tracking the total distinct count of elements, right? Count of total distinct elements that we have seen so far. Then I will just increment it at every step using this formula, which is right minus left pointer plus 1, right? And why I'm doing this is because essentially at every point, for example, right now my right pointer is over here. Once I move my right pointer to 1, uh, still my distinct element count is less than or equal to k, right? So now I need to find all the new subarrays that got added because of adding this particular element in the window, right? And how many new subarrays can be formed by this just one element will actually be equal to the total number of elements which are present in that particular window, right? Because those many combinations can be formed with this particular element. For example, it can be combined with 1, so the string will be the subarray would be 1 to 1. It can be combined with 2, so the subarray would be 2 1. It can also be combined with itself, a single digit subarray, which is also a valid subarray, and that will be 1 1. So essentially I need to calculate if my condition is meeting, if the total number of distinct elements that I've seen so far is still less than or equal to k. What I need to do is I need to add all the new subarrays that got formed or that got added uh, because of adding this particular new element, right? And that will actually be equal to the total number of elements in the current window, because those are the number of combinations that can be formed, right? And that will essentially be calculated using this particular formula, which is right minus left plus 1. It will give me the total number of elements in the current window, right? So that's all. I think that's the intuition behind it. And also, just one last thing, you might be wondering, uh, how will I keep a track of, the distinct count, right? So, or how will I come to know like whether I've seen this particular element before or not? So we can maintain a hash map for that, and we will keep making an entry of every integer, every new integer that we see in that particular hash map. And whenever we see a new integer which is currently not present in the hash map, we will increment our distinct count, right? Because we have seen a new integer now, right? And yeah, and that way we can just keep a track of the distinct element count that we have seen so far using a hash map. So I think let's now jump to the IDE and try to code this together, code this implementation together, and maybe that will also give you a better idea. If you still have any doubts, those will be cleared once we are actually coding it. So how I can do that is I can, first of all, declare a function at most count, and then this will accept an array and an integer k, right? Now, what I need to do is I will first calculate the length of this particular array to start with, right? And then I will declare an hash map to keep a track of whatever integers that we have seen so far, so that, whenever we are trying to calculate the distinct elements, we will be able to make a use of this particular hash map to see if the current element is something that we have already seen before or not, right? So that we can make use of this hash map for. And then I can declare a variable to keep a track of the distinct element count. I can name it as 0, right? And then I can maintain another element to keep a count or keep a track of the number of subarrays that we have seen so far with at most k elements. So that is something that we are going to increase in every step after checking if the distinct count is still less than or equal to k or not. So that's why we will just keep a track of it in this particular variable. And then I will just declare two pointers, start and the end pointer. And I will initialize both of them to the 0 index for now, right? And you can use left or right or start or end. That doesn't matter. And now what I have to do is I have to iterate over the entire array, right? And then I have to keep expanding my window or keep shrinking it, right? So what I will do is I will create a while loop over here, and my condition would be that my end pointer that I'm going to increment when I'm actually expanding my window should always be less than n, right? That's where I have to go, which is the length of the array entirely, right? Now what I need to do is I need to check if my current element that I'm seeing, which is array of end, is present in hash map or not, right? Because if it is not present in the hash map, I can conclude that it is a new element, right? So I will say is not in hash map. So that means it is a new element. And so I will increment my distinct element count by 1, right? I hope it makes sense, right? Since it is a new element, it is not present in the hash map, and that's why we are incrementing the distinct element count by 1, right? That's what we are doing. And then regardless of whether this particular element is present in the hash map or not, I'm also going to update, you know, the value of this particular current element in the hash map to the current index of it, right? And why I'm doing this, because of course, if it is a new element, then obviously I have to make an entry afresh in the hash map for this particular element. But also if it is already present in the hash map, still I'm going to update the value of this particular integer in the hash map, because at any point in time, I want to keep the last index of a given integer in the hash map, right? So if I've seen a particular integer multiple number of times, I will always keep the last index as the value for that particular integer in the hash map. And this will be helpful for me when I'm actually shrinking the window, right? Because when I'm removing the element from the beginning, I will first check if that particular element, the index of that particular element, the from where I'm removing it, is that the last occurrence of that element or not. If it is the last occurrence of the element, then only I will decrement the distinct count variable over here, right? Because then I'm completely removing that element from the window. There is no other occurrence. I can be sure of that. And that's why I'm removing that particular element. And that's why I'm uh, decreasing the distinct element count by 1, right? If it is not the last occurrence, the current index which I'm removing that element from, if that is not the last occurrence of that element, that means, you know, still I cannot decrement the distinct element count over here, right? Because still there is that particular element present somewhere else, right? So that's why I will just keep updating the current integer index in the hash map to wherever I encounter it last, right? So that's the purpose of it. And now what I will do is I will check whether now after updating my distinct count, whether it is greater than k or not, right? Because if it is greater than k, then I will have to shrink my window, right? Only if it is less than k, I will kind of move my end pointer forward. But if it is less than k, then I will have to keep shrinking my window. So for that, I will keep an internal while loop, and I will say while my distinct count is greater than k. That's exactly the condition that we are trying to see, right? If it is greater than k, then I'm going to keep shrinking. And to shrink also, what I will do is now I will check whether, again, the same thing that we were talking about, whether, the value of the current element at the start index that we want to remove, if that is the last index or not of that particular element, right? So what I will do is I will check the index of this particular element, which is at the start position in my hash map. And if that turns out to be the starting pointer itself, that means this is the last index of this particular element that I'm removing. And so in this case, I should actually go on and decrement my uh, distinct element count variable by 1, right? Because there is no other occurrence of this particular uh, integer ever again in the entire window, right? So that's why I'm doing this, and I will also delete completely this particular element from the hash map, right? That's what I'm doing over here. And then finally, I will just increment my starting pointer to the next one because I'm shrinking the window, right? And then finally, once I'm done with this while loop, so see, this while loop will run only if, the new distinct count after updating the distinct element count variable, if that happens to be greater than k. If it is not greater than k, if it is less than or equal to k, then this while loop won't run, and directly we will come over here, and over here we will just update our count variable with the formula that we saw initially, right, while explaining the video. it will be end minus st plus 1, which is nothing but the total number of elements in the entire window, because that is the number of combinations that can be formed. And so that is the number of essentially the subarrays that can be formed with at most k different elements, k distinct elements, right? And finally, I will move my end pointer forward, right? So this is the entire thing. And finally, once I'm done, once I've scanned the entire array, I'm done with scanning it, I will just return the count, right? The final count. So this will give me the count of subarrays with at most k different elements, k distinct elements. Now, as we discussed, we can create another function over here. Maybe we can call it as subarray count, maybe. Uh, okay, let me spell it correctly, first of all. Yeah, count. And this will also accept an array and an integer k. And now what I need to do is I need to return, uh, my at most count over here. Let me just write it, in fact, at most count. And first I will pass array and k, and then I will subtract again at most count, array and k minus 1, right? So this will be my final result, right? So maybe what I can do is now I can just test this particular solution and let's see if it works or not. So I will call my subarray count and I will use the same example that I showed you in the explanation of the problem. So I can say 1, 2, 1, 2, 3, and then finally I will do k equal to 2 over here, right? I think that's pretty much it. Now I can try to run this. Okay, yeah, so if you see over here, this is a previous output, so ignore that. But we got 7 over here, which is the right count.